Today we will walk through a review of decimals, powers of 10, and exponents, and also a little bit of decimal multiplication, just to review the concepts that we talked about in our last 4 sessions. After our review, you will go and you will take a checkpoint on these concepts. So make sure you watch the review closely so that you know that you are ready for your checkpoint. Okay, decimals, powers of 10, and exponents. In our number system, the value of every place is a different power of 10. Powers of 10 can be represented using exponents, as shown in the chart here. So we're going to break this down a little bit because there's some language that you really need to know here. Power of 10. That's the first piece of language that you really need to think about. Powers of 10 relate to this word, place, and this word, value. Okay, so we know that our powers of 10 show place value. Now, on our place value chart, you may remember thinking of ones, you may remember thinking of tenths, you may remember learning about hundredths, and if you're not sure, it's okay, because I definitely know that you remember tens and you remember hundreds. Okay, what these numbers look like is 100, 10, 1, 1/10, and 1 out of 100, and all of the numbers in between these powers of 10. Now we call these our powers of 10 because they have place value determined by powers of 10. Let's start with 1. 1 is just one single solitary number, okay? There's no power of 10 there. You cannot make a 10 out of 1. So what we would write for a power of 10 here is 10 to the 0, because there are 0 sets of 10 in 1. Now if we go to the tens, we would call this 10 to the first, because there is 1 set of 10 in 10. If I asked you, do you have 10 things? You would say, yes, I have 10 things. 10 to the 1, okay? How many groups of 10 do you have? 1 group, so my exponent is 1. In hundreds, you have 2 groups of 10, and we can show this in a couple of ways. We can show it as 10 to the second using that exponent. We can also show it as 10 times 10, okay? 10 times 10, 2 sets of 10, and we see 2 place values, okay? 2 place values. Here we see 1 place value. Here we see no extra place values, right? Now, when you get into something like 1/10, you've made a number that's really small. We call this 1/10, but we also can call it 1/10. I said the same thing, but I wrote something different because fractions and decimals can both be written to mean the same number, even though we write them so that they look different. Now, I would also call this 10 to the negative 1. I've taken my 10 and I've put it on the bottom, meaning it is negative, or a number that is smaller than 1, okay? This is 10 divided by 10. This is 1/10, so it is a small number, meaning that it is a negative exponent. What do you think hundredths would be then? Hundredths in this case would be 1 over 10 times 10. In other words, 1 over 10 to the second, or we call that 10 to the negative second. Okay, so we know that anytime we see a negative number, that means we are dealing in fractions and decimals. Anytime we see a positive exponent, we know that we are getting larger on our place value scale. Okay, here's a few more examples that you can see in this table. Here are the 10,000s, the thousands, the hundreds, and the tens. Now we've talked about the tens and how since you have 1 10, you have 10 to the first. Hundreds are 2 tens, so you have 10 to the second. Thousands, to have thousands, you need 10 times 10 times 10. So that is 10 to the third. 3 tens, 10 to the third, okay? Using that exponent, that little raised number, okay? So the exponent is the raised number, and it tells you how many times you are multiplying that number by itself, okay? Raised number, multiply that number by itself, okay? And you see that because you see how we are multiplying 10 times 10 and 10 times 10 times 10. And in 10,000ths, well, you see 4 place values here, 4 zeros, so 10, 10, 10, and 10. 4 tens, meaning our exponent is also 4. Okay, and just like we discussed You can also go negative. So we talked about this in our first place value. Places less than 1, such as tenths, hundredths, and thousands, are also powers of 10. These are represented using negative exponents. So in something like tenths, which is 1 out of 10, or 1 power of 10 to the right of the decimal, right, which we would always put after our 1, that's our decimal, okay, is 10 to the negative 1. Then we see 0.01. Ooh, that's ugly. I'm going to erase that. We see 0.01, and we know that this is 10 to the negative second. 2 place values past the decimal point, so it's negative second. Then we see thousandths, okay? 0.001, 3 place values to the right of the decimal point, meaning we have 10 to the negative third. Okay, and you can continue this pattern on forever until you have 10 to the negative bajillion, or you have 10 to the positive quadrillion, whatever you want to say. You can continue them on forever. All this means is that you are multiplying 10 by itself that many times. So you have 10 sets of 10 if you're multiplying here, or you have 10 to the negative 10, so that's 1 over 10 times 10 times 10 forever and ever. Okay? So now that we're sure about that, let's answer a couple of questions. Most people know that it takes 1 year or 365 days for the Earth to make one entire trip or orbit around the Sun. Scientists tell us that the amount of time it actually takes is 365.25 days. Here are 4 different ways to write the number 365.25. The first one we see is standard form. That's the number normal itself, to 365.25. Then we see word form. That's when you write it out in language. 365 and 25 hundredths. Okay, so you need to know how to label your decimals. What place value are you using? You can see that in this chart. Okay, you can see the name of the place values there. Then you have expanded form, which is when you take all of the individual numbers and you make them into their full place values. So here we have 3 times 100, that's my 300. We have 6 times 10, that's my 60. We have 5 times 1, that's my 5. We have 2 times 0.1, that's my tenths. And last but not least, we have 5 times 0.01, which is that hundredths place. Okay? The last one you see is exponential form, and that's why we need to know our exponents so well. So here we see 3 times 10 to the second. Now, 10 to the second, is the same as 100. So after you've written expanded form, it's really easy to transfer to exponential form as long as you understand your powers of 10. Now, 6 times 10 is 6 times 10 to the first, using those exponents. 5 times 10 is 10 to the 0. So we see there we have 0 sets of 10, just 1. And so here we are with this number. Then you have 2 times 10 to the negative first. That's our tenths place. And finally you have 5 times 10 to the negative second. That is our hundredths place. Okay? You will see problems like this on the test. So let's go through a couple of examples and then you will get to do your checkpoint. Looking at our next example, we see number 1. It takes Mars 686.971 days to orbit the Sun one time. Write this number in word, expanded, and exponential form. The standard form is already written. We remember the standard form is just the number itself. So now in word form, we would write this as 686 and 971 thousandths, okay? Using the place value to make sure that we know how to label and name it. Being very careful with those THs at the end of decimal numbers, okay? Expanded form. We would start by looking at the place value of each number. So we have first 6 times 100 plus 8 times 10. It's in the tens position, so times 10. Plus 6 times 1 in the ones place, so times 1. Plus 9 times 0.1, or 1/10, because it's in the tenths place, plus 7 times 1/100, and plus 1 times 1/1000th. So listing out each number individually multiplied by its place value. That is our expanded form. Then finally we have exponential form, which is going to look a lot like our expanded form. However, it will use exponents for each of those place values of 10. This would look like this, where you have 6 times 10 to the second equal to 100, plus 8 times 10 to the first, 10 to the first is 110, plus 6 times 10 to the 0, no sets of 10 there, just 1, plus 9 times 10 to the negative 1, we're on the right side of the decimal point now, so our exponents become negative, plus 7 times 10 to the negative second, we're in the hundredths, so negative, and 2, and then we have 1 times 10 to the negative third, thousandths, so we are to the negative third. So when you see something like this, you know how to label using standard, word, expanded, and exponential form. Let's take a look at one more example. I'd like you to pause the video and write your own answers to this question down. Then when you come back, you'll be able to check your work against my answers. You see here that I have written all of my answers. In word form, I spelled it out, 27 and 322 thousandths, paying attention to the place value after my decimal and noting that TH. Okay, then in expanded form, I used each of the place values. So 2 times 10 in the tens position, 7 times 1 in the ones position, 3 times 1/10 in the tenth position, 2 times 100th in the hundredth position, and 2 times 1,000th in the thousandth position. Then in exponential form, I wrote this out using my exponents. So 2 times 10 to the first for 10, 10 to the 0 for 1, 10 to the negative 1 for tenths, 10 to the negative second for hundredths, and 10 to the negative third for my thousandths. Now, just as a really quick review, let's touch on this. So here I have thousands. It looks like this. It also looks like this, 10 times 10 times 10. And it also looks like this, 10 to the third. How many tens do I see to make up 1,000? 10 to the third. Hundreds looks like this. How many place values of 10 do I have? Well, I have 2 of them, 10 times 10, which looks like 10 to the second. Tens, how many tens do I have? Well, it turns out all I have is 1, so that's 10 to the first. Ones, that's going to give me 1, which means how many tens do I have? 0 of them, 10 to the 0. Tenths is going to be my 1/10. Then I've gone 10 to the negative 1. Hundredths, 1 out of 100. Or, I should also write your decimals down here because that's what you're going to be seeing a lot of, which is also 10 to the negative second. Or thousandths, 1 out of 1,000. Or 10 to the negative third. Okay, and we see this represented again. I'll just write it out here. This is like 1 times 10 times 10. 1 over 10 times 10 times 10. Okay, so you see your 10 to the third is there on the bottom, the denominator of your fraction. Okay, now you're going